Okay, so this is the fourth experiment, which is known as a drilling of shafts, and it is even easy when compared to the previous experiments also. Okay, in the drilling of shafts, the main thing you have to determine is the critical speed. Okay, the critical speed is the only parameter which you want to find in this particular experiment. So again, you'll be finding the values in both theoretical as well as the practical aspects. So it'll be deriving the both things and comparing at the last. Okay, so the main aim of the experiment is to find the critical speed. So before we find the critical speed, we must understand what is critical speed. So critical speed is that particular speed where the resonance occur. What is resonance? Resonance is nothing but when the trough of one signal and another trough of another signal coincide, it will create a very huge amplitude. That means the shafts, in a mean sense, I can say, the shafts start to vibrate at a very higher rate in the critical speed. So that is your critical speed. So critical speed is the main suspect for which the resonance is created and the vibration is created. That's why whenever you start a turbine, always this critical speed are taken utmost care so that this critical speed is passed away very, very fast. Okay, so we should discuss all about this, how to calculate critical speed and all in this particular experiment now. So there will be nothing, the experimental setup is very simple. It will be having a flexible coupling at the shaft and the motor, and motor is used to power up the thing, and you'll be having a dimmer stat by using which you can control the speed of the motor, in turn the speed of the shaft. Okay, and there are three types of supports eventually, like fixed supported. Fixed in the sense there will be a hub which in the shaft gets fixed within the hub, and supported in the sense there will be a bearing where the shaft is freely movable within the bearing. So that is the fixed and supported. So we'll be having the two combinations which is possible. Accordingly, you have to change the outfits. This will be very much clear when you have an hands-on experience of that particular thing, which is the fixed and which is supported. So you can have fixed supported, or you can have supported. That means both the ends you can have a bearings, or one end bearing with another end hub. So like that you can have it, but both end fix is not possible theoretically. So that we will not take care. So we will just move on for fixed as supported and supported and supported. Okay. So these are the mode of the drill that we will observe within the shaft. Okay. Here the shaft is fixed. Hope you can see it. And here it is simply supported. So when it is such, the mode of the drill will be something like this. That means you can literally see the shafts bending in this order. Okay. When it is supported and it is fixed. Okay. The same order what we have just discussed. Okay. The next one is supported. If both the ends are supported by a roller bearing, then this is the mode of vibration, mode of a shaft. Literally the shafts will start to vibrate in this particular profile. Okay, both if both the ends are supported, then with two nodes, this is for the one node and this is for two nodes, and again this is for one node and this is for two nodes. So for two nodes, this is the mode shape you can expect, and for the one node, this is the mode shape you can expect. Okay, and this is your experimental setup, guys. Okay, this is how it looks in your laboratory. I said you it has a motor in it. Okay, a dimmer stat and a functioning key arrangement, and this is your shaft. Okay, and these are the supports which I was talking about. Either it can be replaced, guys. It can be replaced either of the ones. So it can be fixed, okay, and other can be supporting, okay, or else the both can be supporting, but both fixed is not possible. Okay, so once the required fixture has been set up within the shaft, okay, and shaft is about to rotate with the help of the motor, you can use such type of arrangement. So this is the on and off key. You can toggle between on and off here. You can toggle between on and off. Okay, this is the indicator that whether the motor is running or not. And here you'll get a reading of your RPM. Okay, the shaft rotation speed is being uh, read here. Okay, here you'll get the reading of your RPM, and this is the dimmer stat which I was talking about. You can rotate the knob all over 360 degrees, so that as soon as you rotate, the speed gets increased. Okay, as soon as you rotate, more current will flow in the motor. Eventually, the more speed will be generated. Okay, this is how it goes. Okay, before I go to the calculation, let me show how it actually works. Okay, look at this. Okay, so as the dimmer stat is rotated here, as the dimmer stat is rotated, the shaft also is being rotated like this. Okay, you can observe the speed over there. Okay, once the shaft is being rotated, you have to slowly increase the speed like this. You have to slowly increase the speed, slowly and slowly, because you have to observe the resonance of the shaft. The resonance of the shaft is being observed at one particular speed, and that particular speed you have to note it down. So I hope in the video is not clear when you literally see it, you can observe the resonance. Okay. Once you observe the resonance, note down the speed, whatever it is there. So here it is 1129 something, right? So you have to note down that particular speed. Okay. Once the resonance is being reached. Okay. Just look at the experiment, how it goes. So this has to be done for both the supports, the fixed supported and supported things. You have to do it for both of the things. So this is how the really hub can be visible. You can even see the mode shape over there. Um, I think it is not correctly streamed or not, but in the video you can observe the mode shape. Okay, so this is all about the experimentation, guys. Okay, coming to the calculation part of it, it's very simple. Just note down what is the diameter of the shaft, what is the length of the shaft, and density of the shaft. That's it. So that will be given in the form of the observations to you, and you have to calculate the value of K for both the mode 1 and mode 2 for fixed supported conditions. So for that, you have a formula here which will be given in your observation. Omega n K is equals to, whereas the first of all natural frequency is given by K square into square root of EI divided by rho A. Okay, if you do 1 by 2 pi, if you add 1 by 2 pi, it will become a natural frequency. This is your angular frequency. And the value of K for the fixed supported segment is given as 5 by 4 n pi by L. Similarly, for the supported segment, it is n pi by L, just n pi by L. Okay, there is no 5 by 4. So you can use this formula to calculate the value of K, which is also known as a mode shape for end condition for which the mode shape occurs. So the end condition can be calculated by using these two formulas here. Okay, you can use these two formulas to calculate your end condition. So similarly, you can calculate for the fixed supported K1 and K2 values. So that is what he has done, and substitute here. Okay, and substitute in the table itself. Next, you have to calculate the critical speed. The critical speed is given by, as indicated above, it is given by K square into square root of E into I divided by rho A. Substitute the required things, you will get the critical speed. This is the angular frequency. From the angular frequency, you have to extract the critical speed. How will be extracting? You have to multiply the frequency, just the frequency with 60, so that will get the critical speed. So whatever you have calculated the value of critical speed here, it is the theoretical one. So whatever you have calculated, that is the theoretical one. So just you can substitute wherever it is in the table. Now, the experimental value you will get in the experimentation itself. I have said it right. So while the resonance is observed, kindly note down the speed. So that is your experimental value, and here is the theoretical value. And all these calculations can be performed for even the mode shape 2 also. The mode shape 2 can be carried out same thing. Okay, just substitute the constant formula, and the supported reactions also. The supported condition, end condition of the shaft can also be calculated. Just the same calculations would be there, except the value of K. K is not 5 by 4 n pi by L, it is just n pi by L. Similarly, you can calculate and reach up to the critical speed using the same calculations for both mode 1 and mode 2. And this is about the experiment. And let's at the last list out all the results, both theoretical and experimental, for both the supports, end conditions, fixed, supported, and supported, supported. And that ends your experiment, guys. Any doubts here?